Today we're going to do section 7, chapter 2, talking about absolute value functions and their graphs. So for our objectives, we're going to answer the question, how does understanding function families help us interpret data? And then we're going to graph absolute value functions by plotting points and understanding the properties of transformations. And then write an equation of the absolute value function based on its graph. So we're going to go from functions to graphing them and then looking at graphs and writing functions. So for our vocabulary, the simplest example of an absolute value function is f of x equals absolute value of x. So this is our parent function. We have through that, the center of that, we have what's called an axis of symmetry. So a vertical line that makes mirror images of both sides of our graph. Do you remember what absolute value functions look like? When we graph them, they make a V. There's a single maximum or a single minimum point that's called the vertex, and it lies on the axis of symmetry. So for graphing, what is the graph of the absolute value function y equals absolute value of x minus 4, and then how is it different from the parent function? So we have, I'm just going to go ahead and pull up a screen. Come on, you can do it. Here we go. Okay, so we're going to be graphing Why are you taking so long? So we're going to be graphing our parent function, y equals absolute value of x, and we're also going to be graphing our function that the question is asking about, y equals absolute value of x minus 4. Okay, based on what we learned about on function families, can you guess what's going to happen when we graph this? Alright, so I'm going to just go ahead and pick x, y values. That's a y. So for absolute value of x, if x is 0, y is 0. If x is 1, y is 1. If x is 2, y is 2. Negative 1, 1. Positive 1, positive 1. Okay, when we take and we go ahead and graph these, see we have 0, 0, 1, 1, negative 1, 1. Oops, pretend that's on that spot. 2, 2, negative 2, 2. So you see a pattern. So there's for that one. When I do my absolute value of x minus 4, so my absolute value of x was 0 minus 4 would be negative 4. 1, absolute value is 1 minus 4 is negative 3. 2 minus 4 is negative 1. Negative 1, positive 1, minus 4 is negative 3. And negative 2 would also be negative 1. So I'm going to go ahead and plot these points on my graph. So I have 0, negative 4, start down here, 1, negative 3, negative 1, negative 3, 2, oops, that should be negative 2. Apparently I can't do math either. Sucks to be you. Alright, so here we go. I'm going to connect these dots. Okay, what do you notice happens? Did the values of our function change at all? Did it get any wider, any smaller? The only thing that happened was it moved down 4 units. So just like when we talked about parent functions, when we add or subtract on the end, that's going to move it up and down. Okay, so this one, oops, just by looking at it, y equals absolute value of x plus 2, what do you think is going to happen to this one? From the parent function, it's going to be translated up 2 units. Okay, so here, just like when we did our function families, this is specific for absolute values. They're exactly the same. So when we have translations up or down, it's plus k, minus k, left or right. it's going to be opposite just like before. Minus h goes right, plus h goes left. Stretch and compression, same values. And then reflections, the only difference is across the x-axis, it's negative outside your absolute value function, just the absolute value function. Whereas with the y-axis, it's the x inside the absolute value function. So we're going to be combining some translations. Which of the four graphs is the graph of y equals x, absolute value of x plus 2, plus 3? So let's break down each part. So, let's see, we did the plus 3 first. Let's do that again. What is this plus 3 on the end going to do? When it's outside the absolute value, it's going to move the function either up or down. Okay, since it's a positive, it's going to move it up 3 units. So from the origin, 0, 0, we're going to go up 3 units. Okay, and then we also have this plus 2 to deal with. Now inside the absolute values, it's going to move it left and right. Remember, we talked about it being opposite. So if it's plus 2, it's actually going to move the function left 2 units. So from the origin, we're going to go up 3, left 2. This one's not it. Up 3 from the origin, left 2. That one's not it. Up 3 from the origin, left 2. This one's not it. Up 3 from the origin, left 2. So our answer is D. That one is our absolute value function. Okay, so what do you think the graph of this one would look like? I want you to go ahead and sketch it. Alright, so I just put an axis on here. So it's this plus 1 means we're going to move up 1. And then we're going to go right 2. Okay, here's where we're going to start from. Now remember, there's no compression or stretch, so our slope is just 1. So we go up 1, over 1 in both directions. Connect the dots. There you go. There's your absolute value function. When we have a vertical stretch or compression, it's going to change the shape of our function. So let's go ahead and make a table of values, and we're going to graph this really quick. So let's see, x, y. If x is 0, y is 0. If x is 1, y is 1/2. Negative 1, 1/2. 2, 1, negative 2, 1. You get the point. Okay, so let's go ahead and graph this on a number line, kind of. Okay, so we have the point 0, 0. Then we have 1, 1/2, negative 1, 1/2, 2, 1, negative 2, 1. What happened to this as opposed to our parent function? How did it change the slope of our lines? It made our absolute value function much wider. So a compression factor, even though it sounds like it makes it smaller, actually makes it wider. Okay, so what do you think this one's going to be? If it's negative 2x, first of all, the negative is going to make it do what? Reflect across the axis, and then the 2 is going to make it smaller. Okay, so go ahead and sketch this one. So you can see from my example that not only does the negative reflect it across the x-axis, but it also makes it so that it's narrower. Because our parent function, let me graph that really quick. We just went down 1 over 1 each side. This would be our parent function. So you can see that a stretch is actually going to make it narrower. Okay, so here's our general form. So the A is our compression or our stretch, and then HK is going to be the vertex of our axis that's the point of our vertex, and then our axis of symmetry is going to go through that x value. So without graphing, what are the vertex and axis of symmetry of the graph, and how is it related to the parent function? So we're going to look at each part. So what is this 4 going to do? So from our parent function, remember our parent function was y equals absolute value of x, it's translated up 4 units. Okay, what does this negative 2 do? Makes it translated right 2 units. And this 3 in front is a stretch of 3. So it's going to be, from our parent function, it's going to be moved right and up, and it's also going to be narrower. Okay, go ahead and write these down really quick, axis of symmetry and the vertex for this function. So with this one, our vertex is 1, negative 3, and our axis of symmetry goes through the line x equals 1. Alright, last thing we're going to do is looking at a graph and then writing a function rule from it. So what's the equation of the absolute value of the function? So we need to look at, first of all, where the vertex is. So if we look at this point right here, what is this point? Well, that's the point, negative 1, and then 1, 2, 3, 4, 4. So we know most of our equation already. So we have y equals a, which is a value that I will tell you what it is in just a second. Absolute value of x, opposite plus 1, plus 4. So then to find this a value, a is just your slope of your line from your vertex going to the right. So what's the slope of this line? Well, if it crosses here, let me grab a different color. So here's a point here, and then it also crosses this grid here. So we go down 1, we go 1, 2, 3 to the right. Our a is actually negative 1/3. So if you go ahead and plug that in, your equation is y equals negative 1/3, absolute value of x plus 1 plus 4. That's your equation of that absolute value function. Okay, I want you to go ahead and write this one really quick, and then it looks like we are done. So just by finding the vertex and then the slope of the line from the vertex to the right, I can plug these in. So y equals 1/4 times the absolute value of x minus 2 minus 1. And that is your equation for your absolute value graph. So here's your lesson check for tonight. Go ahead and get that done. Make sure you have it ready to go over with your partner tomorrow. And you can get started on your 2-7. That'll be due on Monday. And have a good night.